This is 6.7 of geometry. So we've worked with these formulas before, but we're going to use the distance formula, midpoint formula, and slope formula in this section. So write those down if you don't remember them. So first we're going to classify a triangle. So we're sticking shapes into a graph where we can use points, coordinate points. So let's do our got it problem down here. I'm just going to do a rough sketch of this. So we've got a point at 0, 0, at 1, 1, 2, 3, 4, approximately there, 1, 4, and then at 5, 2, 1, 2, 3, 4, 5, 1, 2. Okay, so our triangle looks something like this. Right, you just need a rough sketch to get an idea of what it looks like. If you want to label them, you can. So D, E, F. And they want to know, is this a scalene, isosceles, or equilateral triangle? So an equilateral triangle has all three sides congruent. An isosceles is a triangle that has two sides congruent. And scalene is a triangle that has all sides are different lengths. So we're going to use the distance formula to figure out how long each of these sides are. So let's start out with DE. So I'll label them. I'm going to label these guys X2 and Y2. This one X1, Y1. So square root of my X2 is 1 minus my X1, which is 0, plus my Y2 is 4 minus my y1, which is 0. So that's the square root of 1 minus 0 is 1, so this is 1 squared, plus 4 minus 0 is 4, so 4 squared, which is 1, plus 16, which is square root of 17. We're just going to leave them in our square roots. That'll be easier to compare, and we don't have to mess with decimals. So now let's do EF. So E's already labeled, we'll just keep those. I'll label this one my X1 and Y1. So, square root of my X2 is 1 minus my X1, which is 5 squared, plus my Y2 is 4 minus my Y1, which is 2 squared. So 1 minus 5 is a negative 4. Make sure you're using parentheses around that negative 4. Plus 4 minus 2 is 2, so that's 2 squared. Square root of negative 4 squared is 16. When you're using the distance formula, the numbers that you're going to get are always going to be positive. You would never get a negative 16 there. Plus 4, which is the square root of 20. Okay, and we've got our last side. I'll change these guys up here, make those my X2, Y2. So FD is equal to the square root of my X2 is 5 minus my X1, which is 0 squared, plus my Y2 is 2 minus my Y1, which is 0 squared. So that's the square root of 5 squared plus 2 squared, which is square root of 25 plus 4, which is square root of 29. Those are all different. Square root of 17, square root of 20, square root of 29. This is a scalene triangle. All the sides are different. Okay, so now we are going to graph. We're going to do our got it problem down here. We're going to graph this parallelogram. I know it's a parallelogram because look, there's a symbol right in front of the name of it. That tells us it's a parallelogram. So, I'm going to sketch it. We'll do it down here. So, we've got the point 0, 1. That's our M. We've got our point N, which is negative 1, 4. -1, 4, and that's n. And we got the point 25. And that is P. And we got the point 32. Oops. Which is Q. Okay, then I'm going to connect those. So just a rough sketch. If you want to be exact, you can draw it on graph paper, that's fine. But I just wanted an idea in my mind of what this is looking like. So we've got two different questions. Is it a rectangle and is it a square? So one of our theorems, if you think back to rectangles, is that if the diagonals are congruent, then it is a rectangle. So let's figure out how long these diagonals are. So we'll start with PM. So PM is equal to the square root of, let's call this one x2, y2, and we'll call this one x1, y1. So we get 2 minus 0 squared plus 5 minus 1 squared. Square root of 2 squared plus 4 squared, which is 4 plus 16, which is square root of 20. Okay, and now we're going to do this diagonal here, NQ. Oops. So I will label this one x2, y2. And I'm going to make this one x1, y1. So we've got our square root, so this is going to be 3 minus -1 squared plus 2 minus 4 squared. So this is the square root of 3 minus -1. That's the same thing as 3 plus 1. 3 plus 1 is 4, so this is 4 squared. Plus 2 minus 4 is -2. So this is -2 squared. So this is 16 plus 4, which is the square root of 20. So the diagonals are congruent, so this is a rectangle. So yes, diagonals are congruent. And then they want to know, is it a square? So we know in squares that the sides are all congruent, right? So we're going to do this 4 more times. Okay, so I'll do this side first, number 1. Square root of 3 minus 2 squared plus 2 minus 5 squared. So this is square root of 1 squared plus -3 squared, which is 1 plus 9. And so that's the square root of 10. So now we'll do the next side. Let's do this one, 2. So we'll do number 2 up here. We get the square root of 3 minus 0 squared plus 2 minus 1 squared. So that's the square root of 3 squared plus 1 squared, which is square root of 9 plus 1, which is square root of 10. So we've got two sides congruent so far, right? But here's the deal. Here's a shortcut. We know that this is a parallelogram, right? It says it right there. That symbol tells us it's a parallelogram. And in parallelograms, we know that opposite sides are congruent. So if this angle one, if this side 1 is the square root of 10, that means this side over here is the square root of 10. And if this side 2 is equal to the square root of 10, that means this side is the square root of 10. So all 4 sides are congruent, so this is a square. So since the diagonals are congruent and all 4 sides are congruent, this is a square. So yes, diagonals congruent, and sides are congruent. Alrighty. So, let's draw our axes in. Oh, we're not going to need that big of an axis. Okay, we've got A at 0, 0. We've got B at 2, 4. We've got C at 6, 4. And we've got D at 8, 0. Alrighty, so we can see this is a trapezoid. We're told it's an isosceles trapezoid. So what do we have to do? Well, it says we need to figure out where the midpoints are and connect those and figure out what that special quadrilateral is. So if you have a horizontal or vertical line, see we've got horizontal lines here. You don't have to use our midpoint formula, you can just count. So this top one is 4 long, so here's our midpoint. The bottom one is 8 long, so here's our midpoint. And then we can use the midpoint formula for our other sides. So this one right here, we've got 0 plus 2 over 2, comma, 0 plus 4 over 2. So that's 2 over 2, comma, 4 over 2, which is 1, comma, 2. So our midpoint is at 1, comma, 2. Okay, and then I'm just going to skip ahead here. The other midpoint will be right there. You could do that formula if you wanted. But so now I'm going to connect these. And I need to figure out what this is. So I like to look at the diagonals first because that'll rule out rectangle and square right away. Or it'll point you to the rectangle and square right away. So if you look at our diagonals here, they happen to be horizontal and vertical lines. So we can just count them. So this diagonal here is 1, 2, 3, 4. And the one going across is 1, 2, 3, 4, 5, 6. Diagonals are not congruent, so this is not a rectangle, it's not a square. So I need to see how long these side lengths are. So let's do that one first. Square root of, oh, I should label my points, shouldn't I? This is the point 0, 4, 4, 0. This is the point 7, 2. This is the point 4, 4. And this is the point 1, 2. Okay. So that side that I labeled 1, we'll do 7 minus 4 squared plus 2 minus 4 squared. So that's the square root of 3 squared plus negative 2 squared, which is the square root of 9 plus 4, which is square root of 13. Okay, now I'll do this one, number 2. So that's the square root of 7 minus 4 squared plus 2 minus 0 squared, which is square root of 3 squared plus 2 squared, square root of 9 plus 4, which is square root of 13. Okay, so they're both 13, square root of 13 so far. I was not told that this is a parallelogram, but I can count that with my slope. So if I look at this line here, I go up 2 over 3, so that slope's 2 over 3. This one is up 2 over 3, 2 over 3. And then if I check the other sides, I've got a slope of up 2 over 3, so that's negative 2/3. And if I check this one, it goes up 2 over 3, so negative 2/3. So opposite sides are parallel, so it is a parallelogram. So then I can say, since this side is the square root of 13, this side is also the square root of 13, And since this side is the square root of 13, this side is also the square root of 13. So this is a rhombus. And there's your homework.